Thank you for coming. This is another all control and SICK information session. My name is Jim Staniszewski. I'm the Director of Sales and Engineering at All Control. We've got Russ Nicodem from SICK, a bunch of other all control people on this call. And what I wanted to say, first of all, before I go into a little introduction is, please keep it very informal. Feel free to raise your hand, type in a chat, or even unmute yourself and just interrupt. I mean, we're not, this is not some big production or anything like that. So we're ready to answer any questions you guys have. So like I said, today we have Russ Nicodem. He's a SICK safety application engineer. I think, Russ, you've been with SICK for almost 20 years probably, right?
Yep, 20 years in February. That's correct.
Mm-hmm. Yeah, so almost the same as me. So I've been with All Control for 20 years. Today we're going to be talking about SICK's updated safety portfolio, and specifically some of the products you can see on the screen. Some new safety scanner type products, safety area scanners, safety door switches, and applications that they can solve and help out you in your design of machines, machine cells, anything. If you're unfamiliar with SICK, SICK is known as a sensor intelligence company. You can kind of see on their logo on the right-hand side of the screen. So everything sensors, from safety, presence detection, vision systems, auto ID, RFID, what we would consider sensors, SICK definitely has something. As far as All Control, so All Control is the local in Illinois, Wisconsin, maybe a little Northwest Indiana, premier distributor for SICK. So we've worked with SICK, I think, for 30 plus years. We have multiple application engineers and salespeople around the Illinois, Wisconsin, Indiana area, and definitely we can help you out with whatever you're looking for. And our goal today is to kind of show you what's new, show you some applications that we can solve with these new products. But this is obviously online. If you want to see something or you want to meet us in person, that's what we do. So we have demos of pretty much all of this stuff, or we can get it. We can bring it out on site to your place. We can invite you out to our office where we can demo this product even on some kind of different machinery. We've been doing a few of these information sessions, even though we're kind of opening up a little more from the pandemic, which is definitely good news. We thought this was definitely really beneficial because there is a lot of new stuff out there. There's some new applications that we really can get in and solve at very efficiently with these products. So we thought we could add some value. And like I said before, this is definitely informal. Feel free to raise your hand, unmute yourself, whatever. And at the end, we'll have question session. So if you think of something you want to ask at the end, go for it. And then, yeah, definitely contact All Control if you want us to come out and actually show you these products in person. So now I'll go ahead and introduce Russ, and we'll get going with it.
Thank you, Jim. My name is Russ Nicodem. And welcome to our quarterly safety talk. Like Jim said, this is an informal discussion talking about the new trends and safety topics. Please put your Zoom screen in presentation view, or the view that allows you to see the screen full screen. Do you know what that's called, Jen? So that when we do go live, you'll be able to see the demos really clearly.
If you go to gallery view and then just pin the video you want to see, it should make it larger.
Even going to gallery view will make the make the speaker so that we're full screen. It just makes it a lot easier when I'm demoing live stuff. I'm not super small, and you won't have to look at me. I'll be showing you product. So what we're going to do today, we're going to do a small dose of PowerPoint. And then we're going to take what I call a peek behind the curtain of a safety engineer. We're going to go live. We're going to show you programming live, and then we're going to show you live product in my lab. So at some point, You may have to, it's easier said than done. So bear with me while I'm going through some of this because making the transitions can be a little bit interesting, but I'm sure we'll be okay. So once again, I'm Russ Nicodem, safety engineer out of Appleton, Wisconsin, and I can come and support you. My job is to be in the field, helping you, working with you, and I handle Wisconsin and Illinois, and maybe just a little bit of Indiana. So the topics today, we'll have to cruise through these relatively quickly, but stop me if you want me to hit harder on a certain subject. We want to talk about the new laser scanners, some of the terms we use that we think people know that it means, but they don't. One of my things I want to do today is answer the question, who cares? That's the big thing. Who cares? We have safe HDDM technology. Who cares? If I don't answer that who cares question for you, stop me and say, Russ, who cares? So that's what I want to do. I want to talk about the new network safety laser scanners. Who cares? Why do you care about the networking? The new nanoscan safety laser scanner. Human robot interactions. How do we safeguard them? What's a typical robot cell look like? And how would we safeguard these new and innovative robots in the 21st century? We've got a brand new product. It's relatively exciting, SCANGRID2. It's the first ever solid state laser scanner. It's technically not even a laser scanner, but it looks like one, it acts like one, so we call it a laser scanner. We'll be showing you that live, and I'll be programming that live. New functionality in our door switches. Door switches aren't the most exciting thing in the world, but remembering that sixfold goal for you is to create uptime, make sure that your machines are running good. So we're going to show you some new functionality, even in something as simple as a door switch. So once again, we're taking a look behind the curtain of a safety engineer. So bear with me as we move on. So when we talk about the laser scanners, we are going to take a walk from all the way from a fully collaborative robot where the safety laser scanners can be tied directly into the robot and be fully integrated into the robot. We're going to talk about performance level. We're going to skip over the performance level B type scanner because most of our industrial applications, that's a light, we usually don't get involved in the low risk applications very much. Just know that we do have devices that are rated for low risk applications, but we mainly are going to hit on the performance level C and D. And as you can see on the graph here, the high risk applications would use a scanner, a laser scanner, or a device that is performance level D or above. We have this new product that fits right in the middle. It's considered performance level C. And if you don't know what a performance level is, hit me afterwards or ask me now and I can show you. But these would be the applications that that the devices would be used for. A performance level B device would be something that might be in the, those robots that are delivering pizza to people. They're moving super slow, or they have very little force, or they're guided and there's very little danger. Performance level C is right in the middle where you could get hurt but not hospitalized, and D is where you could get hurt and hospitalized. So we'll take a walk from collaborative robots all the way to industrial robots, both caged and uncaged. First of all, we jump into the first who cares question. What is this HDDM technology and who cares? So the innovative HDDM technologies is the new scanning platform that SICK came out with, I think it was about 6 years ago. And you got to keep in mind that we've been doing this since 1994. So we launched laser scanners 27 years ago. So we know a thing or two about laser scanners. And I've been here 20 years this year, and I've lived every one of these problems. So the HDDM technology stands for high definition distance measuring. So what? Who cares? We call it robustness. So robustness, the first thing that I personally dealt with was EMC optimization. These things are very good in high electrical noise applications. I was on an application where a customer had a grinding machine, and every time the grinding machine went over the existing laser scanner, which happened to be our older laser scanner, laser scanner would go crazy. We put a new micro scan in with the HDDM technology, and it didn't have a glitch. So I know firsthand that it's way more robust in dealing with EMC. Ambient light. This HDDM technology helps you to ignore ambient light. In the olden days, and I have lived it, somebody opens a bay door or there's a window, the scanners go crazy because the sunlight comes in and the scanner gets glare. Or you've got a welding area and sparks fly and the scanners go crazy. One of the other areas that we had major issues with was crosstalk. We used to have to offset the scanners by like 100 millimeters, because if the laser planes hit each other, the lasers would crosstalk and you'd get false trips. So that was a big problem. It was a smaller problem back then because there wasn't as many lasers, but now there's people deploying lasers everywhere. So you don't have enough planes to be able to offset your scanners. So the new scanners are extremely resistant to crosstalk, and we'll tell you why. The other thing that I have lived personally is dirt and dust. I come from the paper mill country, and the paper mill people will call me in and say, Russ, put your money where your mouth is. You know, we've got your older scanner in here, and I'm not going to bash competition, but you know, so I'm going to reference our products. So they had a known dirty application in a paper mill where they were cleaning this thing all the time. It was false tripping. I put a new micro scan in there with the HDDM technology. It's been 3 years now, and I haven't heard an issue. So we know that this scanner is the first and foremost, our priority was solving these 4 to 5 different issues that we were known to cause you downtime. So remember, our job is to create uptime, not downtime. So we've done a nice job in solving these problems, and these problems are solved with HDDM technology, high definition distance measurement. And we'll talk more. I'll show you exactly what that is. So HDDM, high definition distance measurement, is basically this. This is on the left is how a conventional laser shoots out its laser beam, A, B, C, D, E, and it gets a bounce back off of an object, and we measure that. That's called time of flight. And most of our competition that knocked off our technology, what, 7, 8 years ago, that's what they knocked off. They copied the technology and they were there. In the meantime, we were moving over to HDDM, high definition distance measurement. I call it multi-echo technology because I've been here long enough to know that what we're doing is we're sending out these laser beams, but we're pulsing them. So it's multi-echo. So instead of sending a laser beam, we send a laser beam and we follow it up with 3 or 4 more laser beams at a pulse. Then we add all those pulses together. So instead of having 1, 2, 3, 4, 5 different single beams, we have 1, 2, 3, 4, 5 different clusters of laser beams being sent out. With that, we have a lot more information to work with when we're averaging. The other thing that we did was we set some thresholds. So we know that sunlight might be 0 point is no light coming back, sunlight or an invalid signal coming in. They'll be between these 2 plus and minus thresholds, and we only monitor bounce backs or light reflections that are above the threshold. So we can filter out dirt, dust, and mutual interference in sunlight just by knowing the common thresholds of those types of signals. Now we can't ignore everything. This is a safety device, but by far, these are much better than they have been in the last 20, 30 years. The other thing that we do, one of the big issues was crosstalk. And so crosstalk is where one laser beam shoots into another laser beam, into another laser's receiver. So if you can picture 10 AGVs running around a factory, and as they cross paths, all the laser beams are on the same plane. As they cross paths, both lasers are shooting into the other laser beams receivers, and the lasers will go crazy. common problem. So what we do is we shift we have a random phase shifting of the frequency of the laser. Fancy word for just creating a coded scan plane, so that scanner A is different than scanner B, so they know which one, they know each other's light, so that they're not being blinded by somebody else's light. So this is some of the little bit that's behind the scenes of these laser scanners. It's not just a rotating mirror with a laser in it anymore. The other thing that we bring, moving on a little bit to some feature benefits, is we talk about 275-degree scan angle. Here's one great area I say, who cares? So I'm going to explain why you should care about that. The other thing is we can adjust our scan speeds from 30 to 40 milliseconds. You can adjust that in the settings. Obviously, the who cares there is if you can go faster, you can shorten up your stop times or your safe distance calculations. But this 275 degrees always fell on me as who cares? So I created this crude picture yesterday because I was trying to visualize who cares and how do I use this. So this is 190-degree scan angle at the bottom here, and this is 275 degrees. This picture in here is a robot. If I want to put the scanner on the corner of this robot and be able to cover the full two sides of a machine, I need 275 degrees scan angle. So my picture is pretty crude, but it was the best I could make yesterday. As you can see in here, these dotted lines are my maximum area. So I'm not even using the maximum 275, but this is very common. So now instead of one scanner going here, one scanner here, one scanner here, instead of 4 scanners, you can do the whole job with 2 scanners, one here and one here. Does that make sense? That's the who cares about the why 275-degree angles is important.
Russ, I'm going to jump in here just real quick. I think one of the good things to know about SICK in general and these safety scanners is that, I mean, the stuff we're talking about today is like 5th or 6th generation of scanners. I mean, we go back, like Russ said, to the 1990s with the PLS safety scanner, which was very simple, but started basically this technology. And a lot of the stuff we're talking about today has been learned over the years or developed over the years to take care of these problems that we've had as we've come along and seen the issues that even SICK's product at the time had. So I think that's a good thing to note, is that, you know, when we're talking about, hey, this new safety scanner, this is not like a brand new thing. It's something that's been developed and perfected over the years. And I think that's kind of the best part about SICK, is that a lot of this stuff we're talking about is common problems that, you know, most other companies and even SICK has had with their scanners. So big benefits, and, you know, industry knowledge has really pushed us this way. So it's kind of you know, perfection off of you know, past observations.
Yeah, that's exactly, Jim. And I thanks for saying that, because that is exactly what's happened. When we launched, this was the 4th generation of the micro scan. When we launched this technology, we didn't worry about frills and thrills. We didn't even worry about networks and connectivity. We worried about robustness. The first thing we said was, we need these scanners to work. And so that was what this technology was all about. And then we wanted to maximize the scanning area. And so then we started to advance on to 9 meters and networks and things like that, which we'll talk about. One thing to note that sometimes people misunderstand also in the who cares category is when we say, hey, a scanner has 9 meters, a scanner has 4 meters, and a scanner has 5 meters. What we're talking about is the distance from the laser scanner to its furthest point. So in the case of this picture, I have 9 meters to the left, I have 9 meters down, and at 9 meters out. So you have a lot of area you can cover with these scanners. If you chose a 9 meter, you could have a 5.5 meter, then you'd have 5.5 meters to the left, 5.5 down, 5.5 out. So you have got a lot. If you were going straight across, you would have 11 meters or 18 meters, straight across if I didn't, make this 90-degree turn. You can do a lot with these scanners, but my main point was to be able to cover two sides of a machine with one scanner is a huge thing, and people just don't always get that. We didn't even have a graphic for it, so I made one. So when we say 4 meters, 5.5, we're always talking about the protective field. There's also a warning field, and you can go out to like 60 meters. That's also the range that we're using for measurement data and things like that. So in this 4th generation of scanners, this is called the microscan. In 2016, we launched the HDDM technology. It was just a core IO scanner. Works great. It's here. It's been working great for, well, it's 6-7 years. Then we stepped up and we said, hey, we need networks. We were the first people to launch an Ethernet SIP safety network. So our scanner is fully integratable into a Rockwell safety PLC, or SICK has its own Ethernet SIP safety master as well, if you don't need an expensive safety PLC. And then we launched Profinet, so we can also integrate with Siemens and whomever on Profinet. And this is completely integrated safety over the network. We have our own, what we call FE Pro. FE Pro is really just Ethernet SIP safety. We just call it FE Pro because Ethernet SIP safety is a Rockwell term. And then this year, we're really excited that we have the first ever EtherCAT network scanner. So it's over FSOE, that's functional safety over EtherCAT. We just launched that this year. So if you're a back-off person or you need EtherCAT, we have all of the variants. So people come to us. I get the question, why, Russ? Why do people work with SICK? We've got you covered, whether you just want an inputs and outputs, or you want to be able to fully integrate into your network. So we have the longest range in the market with the microscan, 9 meters, 275 degrees. But then we launched the smallest scanner on the market. So the smallest scanner still has the 275 degrees, still has all the smarts, the HDDM technology, but it's super small. It fits into any small space that you might need. So it's very compact. It's got all the reliability of the microscan. It uses basic Core IO, so it's very simple to program. But yet you can still get up to 128 fields if you think you really need that many. It has a really nice display that you can use. You can look at the IP address, its settings and error warnings and things straight off of the screen. All of these program in the same safety suite called Safety Designer, and they're very easy to program these days. The days of difficult scanners to program are long gone. They program over a micro USB, so no more special cables. One thing to note is all of our products now come with standard cables. So you're not spending $2,000 on a product and $1,000 on cables. We've gone away from that, and now most everything will be a standard cable. A standard micro USB cable. You can get these with Ethernet. You can get them with safe IO. So if you're used to inputs and outputs, you don't want to deal with bits and bytes, the NanoScan is great for you. This is our low, product was priced extremely low because it was made for the automatic guided cart market. So not only do you get all the robustness, all the SICK qualities, you get it at a low price as well. It has a system plug approach, and as we always have done, cloning is built in. So if you ever have to replace a scanner, you pop your system plug off, put a new one on, and you're up and running. These would tie into your network. They do have non-safe Ethernet on board, so you can use that Ethernet to do navigation. You can use it to tie to your HMI or your computer, but your safe bits or your safe outputs would always go back to a controller or to a safety relay. One thing that people don't always realize is that you don't have to have your fields be a perfect square like we have here. You can have them be any shape that you want. You can have a heart shape if you want. We can even have a contour as reference as one of our fields. And you can have up to 8 simultaneous fields at one time. So I can have a field to the left that is set very robustly, say it's at a robot or a paper machine that's got a lot of dirt and dust. I can have that set to have to see the dirt 8 times before it trips off. So it's very robust. But I can also have an area to the right, maybe where the door is, and I can teach it that door and say, if that door opens, tell my machine to start to slow down. And then when somebody enters the cell, you're already ahead of the game. Your machine's already starting to slow down, so you don't have to emergency stop it. So we've got a lot of capabilities in our fields. So the nanoscan, which we said we would talk about, it's 3-meter range. So it is smaller, but it's got a smaller range. Still gives you that patented 275 degrees. It hits the highest performance level, and it gives you a good amount. When we say measurement data, that's also your warning field range. So you can go out 40 meters with measurement data or your warning field. You can get it as simple as an M12 8-pin, which is again is your standard cable, or you can get it with an 8-pin with Ethernet. And we'll show you some reasons why you might want to get it with Ethernet. And it comes in Core and Pro. In our world, Core usually means industrial settings. Pro typically means that it's used on an AGV or an AGC because it'll need a lot more field sets. So normally in your world, if you're not building an AGV, a Core scanner would be right for you. If you don't want Ethernet, you don't want any connectivity, just use an 8-pin. That's a very simple and very common. But if you want to have Ethernet data come out, maybe have visualization out in your office or something, you can get it with Ethernet, and you can add that later too. Some of the common applications we get into are robots. We have coexisting robots. We work with them all the time. My world is full of robots. A coexisting robot is a robot that's behind a cage and you coexist with it. Similar to me living with my daughter. She's downstairs, I'm upstairs. We're in the same house, but we don't interact. So a coexisting robot has a simultaneous process, but it doesn't work in the same workspace. A cooperative robot, which is where we really shine with the laser scanners, is where you're working in the same workspace, but you're doing a sequential process. So what that means is when the robot is doing one thing, you're doing something else. There'll be this middle picture. So if this person walks into the cell, the robot is outside the cell. When the robot is inside the cell, the person is outside. You're sequential. It's like a dance. You don't ever touch each other, but you're working in the same workspace, but it's sequential. And then the newest thing that people have been talking about is the collaborative robots. And as you can see, as we increase interaction, we increase the amount of time we're spending with the robot. That's called collaborative. And that by design, you would share a workspace and you would work with it simultaneously. So hopefully that makes sense on robot cells. So we'll just walk through these quickly. If I had a traditional caged robot, how would I protect it? I would probably use the STR1. That's one of the door switches we're going to be talking about. And that would be put on the entry door. I might need light curtains at the entry and exit of the product. We need product to flow in and out. I would probably use a set of light curtains that has built-in muting. So we have muting built into the sticks, so you don't have to have a controller. And it allows your product to come in and product to flow out, but keeps people out of the cell. This will all meet performance level D. and the robot will be protected, or the humans will be protected because you cannot get in this cell. Makes sense? That would be a coexistent robot. So then we would, if we go into a cooperative robot, this is where the networks really come in handy. And the RIA 15.06 references the safety rated accesses or soft limits or zones. Some robot manufacturers might call them walls, where the robot can only work in certain areas depending on where the person is in the cell. And this is where we call SIM 8. 8 simultaneous field sets comes in really handy. Person walks into the robot cell, gets into cell number or zone number 1. The robot says, hey, I'm going to slow down to 25%. Walks into zone number 2, slows down again. Then he's working in number 3. He's going to put this box over here. The robot is only allowed to work on the right-hand side of the picture because they would have a limit. It can't come over here because the person's there. This is really easy to do if you use network scanners. You can do it hardwired, but it takes a lot of wires to be able to do this. So this would be one of the real good reasons why, if your robot manufacturer says, do you want the DCS, the dual check safety for FANUC, and do you want the Ethernet SIP safety, Ethernet SIP safety, say yes, because you can do some really good stuff with it, and it doesn't require anything more than power and an Ethernet cable. When we're talking about robots, the next thing is talking about collaborative robots. What do we supply? We supply the monitored safe stop. So that monitored safe stop is when the person is at the robot and working with it. We also supply the speed and separation monitoring. So what that is, we know the approach speed of the human and how far they are away from the hazard. And then we send signals to the robot to tell it what to do. Hey, slow down. Hey, go to power and force limiting. We give it signals and then it replies back, got it, I'm there. When you're working with any type of these robots, industrial, collaborative, cooperative, or coexistent, we have a kit for you. And these kits are called SBOTs. Who cares? Well, an SBOT is a do-it-yourself kit, includes all the product, the programming and instructions to make it easy for you to deploy your robot. The latest thing that we came up with, and this was just launched about a month ago, and I'm in the process of working with one right now, is the first ever fully integrated robot safety system. So I just went out to the UR robot site. And so what we do is we've got a partnership with UR. Our scanner ties directly into their pendant. No SIC software involved, no safety designer. Everything is programmed over the UR cap. So it's a first of a kind. I'm working on putting one in with my partner in Minnesota. It's becoming very popular because you don't need any controller, any external software. So the next product we need to move along is the first ever SCANGRID. It's the world's first LiDAR multi-beam laser scanner with solid state technology. Ooh, you know, once again, who cares? Well, the who cares on this one is that because it's a solid state, has no moving parts, means it's very inexpensive and it works really well, and it should never die because the motor's not turning. There's, you know, it's just a bunch of lasers inside of it. We just launched the first variation. You can get it in IO, inputs and outputs, or can open. This is designed for the AGC market. What it is it's a scanner with 32 laser pulses using time of flight, measuring the distance to the person and reporting back. It has a 1.1 meter range and 150 degrees. So this sensor could be used, it's a safety rated sensor, but I highly recommend that it could be used as just a sensor as well, if you wanted to. So this is what's under the hood. You've got 8 different laser diodes. Each one has 4 lasers. and receivers. Very simple concept, and I'll have one here on my desk to demo for you. The next one isn't a super exciting product, but it is, once again, all about uptime. It's called the STR1. The main thing with the STR1, this is an RFID tag or an interrogator and an RFID tag. So this is not coded magnets. We all hate the coded magnets because you get the discrepancy faults and so on. This gives you OSSD outputs, which are safe outputs, which would go directly to a PLC or to a safety relay. The things that make it different is highly visible LEDs, and they added in, they've got 14 millimeters of misalignment allowed, and they added in increased hysteresis to avoid this triggering on, off, on, off, on, off, and you'll get a little yellow light that says, hey, my door is starting to sag and I'm about to shut your machine off. So that's one of the things that they added into a simple device like an STR1. When you get an STR1, you have a choice. I just want to touch on this of universally coded or permanently coded or uniquely coded. I usually recommend you go with unique or permanently coded because those are considered to be high coding levels. When you go to the high coding levels, the only thing that's mandatory is that you have to use non-detachable fixing fixing screws. So you got the screws that you can't remove without a special tool. If you were to go with a lower coding a level like a universal, you're mandatory based on ANSI B11 to do one of these other things to help protect the actuator, mount it out of reach, have a physical shield or whatnot. But if you go with universal or unique or permanently coded, you do not have to take any other precautions except using the right screws. And the screws look like this. So with that, let's attempt to go live. Actually. So I'm going to do this a little bit backwards only because it makes it easier because I'm already sharing my screen. What I'm showing here is the SCANGRID. And we're going to look at the SCANGRID, and I'll show you the physical product after. Like I say, it's a little bit backwards. So in the SCANGRID, one of the nice things about the SCANGRID is I'm programming this with no power. And I'm also, these squiggly lines, the blue lines, are me moving in the area. So we'll show that. I'm in the Fields tab, and I can be on protective and warning field. Warning is always yellow. You see how squiggly these lines are? Those are your 8 laser diodes, and they're not, you don't get as tight a resolution as you would on a regular laser scanner, but this is a very inexpensive device. So if I wanted to add a field set, I would say, yep. Sorry about that. So if I want to make a protective field, and let's say I wanted to, just to show you that I can make any shape I want. Some people think, hey, Russ, Yeah,
as Russ is doing this, I'll maybe comment. I think
what's that?
I'll comment while you're doing this. I think one thing that is maybe a common misconception is that when you see these safety scanners in the field, people don't always understand that you can draw almost any shape you want. It doesn't have to be a rectangle. It doesn't have to be a semicircle or things like that. You can draw, ignore certain objects. The only thing you can't really do is look around things. So obviously it's a single point the lights are coming from. So you can't look behind something. But But other than that, you know, you can draw your fields anywhere inside that protective field radius. So when we talk about the safety, what do you call it, the safety distance or safety rated distance on these scanners, we're talking about a radius from the scanner. So we have out there, I think, I'm not sure on the SCANGRID, if you zoom out, you can see it shows you the extent of your safety, potential safety field. That's that dotted line. So anywhere inside there is where you can draw your safety fields. The warning fields can usually go out quite a bit farther, but safety fields are limited in there. So yeah, I just wanted to make that point, because I mean, I've been around safety scanners for 20 plus years, and I still get asked a question like, oh, well, how do I ignore certain things because I can only draw a semicircle? So that's not the case. But like Russ just showed, if you draw out longer, it just kind of limits you to that maximum range.
Right. As you can see, it's super simple to work with. Oh, I made it a little bit too. So I just created fields. I've got a protective field, a warning field. I can make this any shape I want. I can create a second field set. Within this field set, I can create a third one. I can get rid of the third one. So it's really easy to work with. If I want to make another warning, I'll make another warning. Need that in essence of time. On this scanner, I have, remember, you can use this as a sensor. You can go PNP or NPN. The only safe way is PNP. Let's say you wanted to use it as just a sensor, you know, you want an area detection. You could use it as an NPN or PNP. You can give it your monitoring result. That's your warning field. And then it automatically assigns your inputs and your outputs for changing field sets. When I go into my, I want to drag something over, boom, done. It will have NFC, and near field communication will allow you to do cloning, suck the brains out of it. And near field communication is the communication with your cell phone. So with that, I'm going to stop going live so I can actually show you the, or stop sharing my screen so I can show you the product. Move the camera. This is where the fun stuff begins. Let's go.
Yeah, just in case you guys are seeing just a small video, if you right click and say pin to Russ's video, you'll see it bigger.
Right. So this is the SCANGRID that we're talking about. No wires. I don't have to power it up. I'm just doing I'm powering it up over the USB. I set it here. So just a simple USB cable, so you can pull this off of your shelf. Your shelf. You know, the question is, who cares, Russ? Well, I don't have to find an M12 8-pin. I got a customer who's in trouble. They need one of these. I can plug into it, download the program, and send it. Not have to worry about finding a power supply or anything like that. It's good to go. It's the first device that we have that we can actually program without any power. It uses a USB-C type connection, which does give us the power to the program over. Get that out of the way. Hopefully, the next device was what I call, not the most exciting. This is the STR1. This is your RFID interrogator, and this is your RFID tag. Door closes, green light goes on, highly visible green light. But then if you back it off, notice the huge difference or distance I'm able to get with this. And then I get that yellow light that says, hey, dude, you're right on the edge. You're getting close to danger zone. But I'm quite a ways away. Your door sagging, and you go, ah, yeah, I sagged too far. So you get a lot of play. In the olden days, we used the magnetic door switches. And every time if you came in crooked, you'd get a discrepancy fault because you'd get a contact closing before the other. This is all discrete OSSD outputs, no more no more issues with discrepancy faults. So this is one of our ways of getting your uptime. The next thing we're going to talk a little bit about, the laser scanner. Let's see here. So I know it's not the easiest to see. I have a robot here. You can see that. Hopefully you can see that it's spinning super fast. This is a laser scanner, and behind it is a safety controller. This is what we would call an SBOT, a do-it-yourself safety robot kit. This is the generic one. So this kit that I have in my lab works with just about any robot on the market. You'll see here I have a warning field, protective field 1, and a protective field 2. And I have a reset button and an e-stop, your basics that you need in a robot. So the idea behind this is this kit has safe sequencing built in. And safe sequencing is critical in robot applications if you want your robot to be able to be what we call speed or automatic restart. So the way this works is I've got my little guy here, and he backs into the first warning zone. There's a little click. That click says, hey, I sent a signal to my robot to go to reduce speed. I know that after 500 milliseconds, reduced speed is met. So it takes my protective field 1 and shrinks it. It does that because it knows that my robot's already slowed down. So my stop time is way less. So I can give my person a lot more room to work. This is really critical in those collaborative applications because your robot's moving is slower. You can get closer, you can get more stuff done. You're not completely stopped, so you're at least getting production out. If the person exits the cell, it goes back to high speed. He comes back in, goes to slow speed. He gets into this other protective field. He can still work. The robot doesn't change its speed at all. But then when the person gets into an area where he's too close to the robot, according to the standards, anytime you could be hit by a robot, even if it's collaborative, you could be hit in the head, it has to come to a stop or be working in a different area. So if this person does his chore, this would be a sequence and designed to do this, and then he backs out. As he backs out, the robot starts back up in slow mode. And then as he exits completely, it goes to full speed. Saves on your robot and keeps your production going. So you say, Russ, who the hell cares? Well, what does the sequencing do for you? So you got the guy coming in, he's doing his work. He gets in here and the robot stops. And now something falls behind the robot and the knucklehead goes behind the robot and says, no, I got to get that box out of there. Well, in this case, your robot, you don't want your robot to stop. So the sequence monitoring says, hey, he's out of sequence. So now he gets off the robot, goes back out of the cell and looks around and says, oh, darn, my robot's not running. Why isn't it running? It requires reset because you broke the sequence. So the sequence monitoring is really critical, and it's built into most of the SBOT kits. You would use the sequencing if there's an application where the person can get behind the robot or up on a conveyor or something like that. It becomes it becomes necessary. Otherwise, you have to use manual reset. And manual reset costs you time, which costs you money. So this is the most generic of all the SBOT do-it-yourself kits. We're actually making pretty good time here. The next scanner decided to move from left to right. The next scanner is the nanoscan. Okay, focus. Okay. Sometimes getting the camera to focus can be a bit interesting.
I think while he's getting that camera to focus, so I can make a comment that so originally we talked about the solution with the 6 scanners and the controllers with the UR robot, but essentially, I mean, these SBOT solutions can be used with just about any robot package that's out there. All control and specific, we deal with the TechMan series of collaborative robots that has multiple safety inputs, and you can kind of program what the robots can do. So this could do the same thing with that solution as well. And you know, I mean, there's other big names like FANUC, KUKA out there, and yeah, we can kind of plug in and work with those guys just as well.
Thank you, Jim. Yes, that is the case. We call this generic for that very reason. If I want to go to TechMan, I looked at the interface, you have all the interface required to use this with the sequence monitoring. What we would provide to you would be pretty much everything you see here. Scanner, there's actually a controller behind it. E-stop and reset buttons. And then we would provide you also all of the software that goes into both the scanner and the controller. So you have a very good starting point for your robotic kit. And customers love that, because if you have 10 engineers writing 10 programs, most likely you're going to have 10 different operations. So by using the SICK software, which is written by TUV certified engineers, the system is guaranteed at performance level D. You're guaranteed, you've got the assurance that it's done right. So that's why that's generic. If you've got a Yaskawa, you'd buy an SBOT YA Yaskawa. If you've got a FANUC, you'd buy a SBOT FA for NUC. If you've got a UR, you'd buy an SBOT UR cap if you wanted one that's fully integrated. So, and if you were working with the TechMan, you would buy the UR generic, and you'd get all of the software and the E-plan and the wiring diagrams and all of that come with it. So the next thing we have is the NanoScan. And what I want to talk a little bit about is you can get the microscan and the NanoScan with or without network. And why would you get the network? If I want just I/O, why would I want the network? Well, what I'm going to show you here is this is an I/O scanner. So I'm getting the hard wires output. My camera should be able to focus. This is a visualization tool that we have. Hopefully the focus is good, reasonably good. And what this software is designed to be put on your HMI. If you've got an HMI, a Windows-based HMI, or if you have maintenance people that just want to be able to plug into the scanners, plug into your network, go into the IP address of the scanner and say, what's that scanner seeing? If I had this scenario where I had something very, I think I can get it so I can get both here. Well, so I've got something sitting right next to the scanner plane here. You'd really want to know that, and I can do that without even opening up Safety Designer. What this does is it shows what the scanner is seeing live. It tells me, hey, I'm in the medium zone. You name the zones. I've infringed my cutoff path 1 and 2. And if I increase my zones, this one's set for slow. You can see slow, medium, and high. And what the software does, it just gives you a visualization of what's going on with your scanner. If I'm getting false trips, if there's something sitting in the area that I can't see, what's going on with the scanner. So we're in the live view. So you got to picture this as being the HMI. So you got the live view, you've got information, and then I've got event history. And under event history, I do an update, and I can get all of the different histories of things that have happened in the past. The other thing that you get on this screen, I can also zoom in and zoom out, because remember, it's a touch screen. I can make it smaller. It gives you some more visual. So all of the lines, that's me moving around. So coming in, coming out. Okay, I've only got one safety zone. I've got two, so it's giving me which safety zones. This little spot here on the microscan, this was designed for the microscan first, is to give you your dirty lens percentage, and it'll actually show you where your lens is dirty. So one of the things I wanted to go into was the event history. Comes in pretty handy. So if I click on it actually replays the event that happened. So if I see this going on, I know that somebody walked into the area. It wasn't like mutual interference, that somebody physically walked in. It'll tell me on the screen that I was in the braking full speed, and that my infringement was 0.37 meters away at angle 81. So you get a lot of data that you can take back and say, well, what do you think was going on? And it'll tell you when it happened, 9:56:07, 9:56:21. So it's showing me coming into the area, and you can get a good diagnostics without having to pull out a complete computer and getting Safety Designer. This gives you a great snapshot. If you've got Ethernet, you could have this on the network, and you could even remote in and get this data out without having to open up the full software. So I think that was my last live portion. So we can open this up for questions. We are right on time.
Great, yeah, thanks, Russ. I mean, if anybody has got any questions or wants to see anything specifically that we went over, feel free to just jump in right now. I think, like we said, there's, being that this is the late, I don't know, 5th or 6th generation of scanner type products. I mean, now we kind of see we're getting into the area where, we're making specific products for specific type of things. Like Russ said, yeah. The SCANGRID is going to be very good for AGVs and AGCs, and it's small, can fit right under the bottom. We've been working on a couple different applications where it's going to do just that on, moving carts, either moving automatically or by human control. And one of the things that we mentioned, I mean, you saw that he can program it without plugging it into actual power, just plugging into a USB port. That's a real big deal a lot of times for people that have automated vehicles, because they're almost always controlled by a battery. And you when you're looking at the electrical equipment to put on there, you want the stuff that has the lowest power draw. So that's one of the biggest things for those type of applications as well.
The other very exciting thing about this product being that is that it's going to have programming over NFC as well. So that's going to be really nice. So if you do have typically if you have one of these, you have 4 of them, and you want them all to be the same, you'll be able to take your cell phone or your iPad out there, hook it up, or just put it by it, and it'll suck the brains out of it. You can take that program and clone it into the next scanner just with a cell phone. So that's going to be really cool. Keep in mind, it doesn't have to be used for safety. It's priced right, so it could be used for just area detection, or where you've got safety mats. And safety mats are historically get damaged. You want non-contact safety mat. Put this down, it's going to scan the area. Boom, you're in good shape. You could mount it as an access door vertically. The one thing that it doesn't have is contour as reference. So you'd have to, you'd want to screw it down with tamper-resistant screws, but it's like a one-sided light curtain. But you also have to keep in mind that its resolution is 50, 70, and 120 millimeters. So it's more like body detection than it is hand detection. But I can tell you, this thing doesn't miss anything. I mean, when I get super close, when anywhere in this area, that's why I put the cable back behind it, because it keeps picking up the cable. They're got a very good resolution, and as all SICK products are, we always overkill them when it comes to performance. So if we say it can do it, it can probably do double that, and that's what I find with this one. It's a really nice product. But the biggest point is, you don't pigeonhole it into it being a safety product only. At its price point, you can't find anything like it that can do what what just giving you area detection. The only thing I would tell you is that the safe outputs are OSSD outputs, so they're pulsed outputs. So if your PLC is going to pick up that pulse, you may want to use the warning field and then just be a PNP output, and that'll be a solid output. Because OSSDs are safe outputs, and they always have a high, and then they drop out for like 200 microseconds, and then they come back. That's part of the testing circuit in the safety. So if you're interested, I got the products. I'm glad to come and visit you. I work with Jim and Sydney, and I'm in Illinois all the time, so I'll be more than happy to bring the show to you.
Russ, quick
Great.
question. Typical communication between our scanner and a robot, does it directly communicate via Ethernet, Ethercat? Or do you
Yes,
put a
yes, and
plug
yes.
into the-
Quite honestly, the majority of them are still hardwired, meaning that you have a protective stop, a safety rated monitor stop, a warning zone or warning. So a lot of them are still hardwired, and that's only because people haven't gotten used to using the networks. Highly recommend that you go to the networks. So it's now probably at 50-50. I get customers that say, I have to have the network, because if you have, well, let's do the math. If you have eight simultaneous fields, you have, and each one of them has dual outputs. So now you've got, that's 16 wires just in outputs. Now you have to have inputs to change those field sets. And now you've got, say, 16 wires for changing field sets, and then you've got power. So, well, actually you end up about 17 pins, 17 wires plus power. So around 20 wires to wire up if you do it hardwired. If you go with the network, you've got 2 wires, brown and blue is your power. So that's 1 cable back. And then you've got your Ethernet cable, and you're done. You're not done. You just program in the scanner, and then you just have to look at the bits as inputs. You take the bit, for cutoff path 1, and you put it into your logic, just like you would a hardwired output from the scanner or input to the controller. So we're getting near 50-50, but it's shifting fast, and we're talking really fast right now. Every week I'm dealing with networks right now, where a year ago I had to push the networks. Now it's becoming my life, and I highly recommend that. It is the way to go, especially if you're going to use the capabilities of your robots. They've come a long ways. Let us do our job, let them do their job, communicate over the network.
How about on the collaborative? Do you typically package in that a speed kit?
Yes, on the UR robots that just launched about 3 weeks ago. So yes, and that is becoming super popular. I've been out on one installation. I don't do installations, but I get involved with them. We have a UR robot in the lab, and we are the sole provider to the collaborative robot company UR. And then we have more of those kits coming that go directly into the robot. The historic robots, the FANUC, the TechMan, the Yaskawa, they still require something in between. The laser scanner, safety controller, and then the safety controller communicates to the robot. Something has to be the master. So that's the caveat for the networks, and even for the hardwire. The nice thing about it is that we have an inexpensive master. So we have an Ethernet SIP safety master. So if you're buying a FANUC robot, and they ask you, hey, do you want the DCS? That's dual check safety. You say yes. That's a no-brainer. And then when they ask you, do you want Ethernet SIP safety? Say yes. It's going to open up a lot of doors, and it's going to future-proof your robots. You're going to not regret this down the road. I guarantee that. You can use it today, and it's going to be even more useful down the future.
Yeah, I think the real way, I guess, to answer that would be, yeah, like Russ said, we can do yes, yes, and yes. We can do all types of, you know, solutions, whether it's hardwire communication, SIP safety, safety controllers, you know, but there's not going to ever be really one standard way to solve every application. So, you know, we're talking a lot about robots here, but you know, standard machinery is the same kind of way. If you got safety controllers, a lot, you know, I've seen machines with, you know, Allen Bradley safety guard master, I think they call it. You know, Omron or SICK also have different safety protocols, different safety controllers. So, you know, every machine, every application is going to be different, but we have pretty much a way into every type of solution or every network. So, you know, with this product, whether it's the scanners themselves or scanners paired with a SICK safety controller, you know, we have the ability to jump into almost any controller, any network, or just a basic machine with safety relays.
What I need to know when you call me or call your rep is what type of robot do you have? Does it have a safe network? Does it have, you know, what's its interface look like? Mainly if you can tell me the robot type and whether it has, you know, Ethernet SIP safety or EtherCAT safety or Profinet safety, I can pretty much guide you into the right kit. Or if it doesn't have any of that, I got the solution in many cases right there. And that will be hardwired. Every robot's got a stop function. Every robot's got a monitored stop function. It's got an emergency stop function. They just all call them something a little bit different, and that I can tie into.
Sounds good.